Good afternoon. We've made it to Thursday, right? It's Thursday, October 22nd? Yes? Okay. And we are continuing our discussion of where we're sort of in topic 4, where we're talking about the research tools, and we almost got to the end. We'll just finish that up, and then we're going to spend the time today talking about sampling and external validity. Is this where we got to? Great. Are there any administrative questions? No? No, none? Have you looked at the homework? Yes. Worksheet 4, yes? Have you got any questions about that? You should have pretty much all the information you need to do it. There's a new section. The new section is the research proposal section. Yes, did you notice that? Where you get to put together all of the skills that you've been gaining and propose your own research. So you get to just say, in order to address this hypothesis, here's what I would do. Here's how I would define and measure my predictor variable, define and measure my outcome variable, and here's the procedure. This is how I would do it. I think I've given you the limitations of I've given you unlimited resources, so you can propose whatever amount of resources that you feel necessary. But I think I have limited to you must obey the laws of nature. You can't invent a time machine. You can't, you've got to be, it's got to be real. And I think that this week you are challenged to limit yourself to observation. So the exercise is to limit yourself to operationally define both of those variables only using observation. And that should make you pretty happy this week, because I think they both lend themselves quite nicely to observation. Next week, same hypothesis, and you'll be asked to limit yourself only to survey. And so you may need to rethink what information would be interesting from a survey of these same variables. And then for worksheet 6, you get to manipulate something and conduct an experiment. All right. Okay. Moving right along. All right. Oh, yes. I believe that you get a chance to evaluate your construct validities and your overall procedure, your overall research method. Okay? If I've just used the word, so when I use the word construct validity, here are some cues. That's just talking about that one variable. But if I say, what's your entire research procedure, and now critique it, then that would be a broader use of that term. Is that okay? All right. Okay. So on Tuesday we talked about observations and we talked about surveys. And this slide is very much about the concept of a method mismatch, right? That surveys are an appropriate method match for opinions, for attitudes, but not for behaviors. So just to review what we were thinking of here, when you are asking survey questions, you want to make sure that you're asking information that that your participant is aware of. And so that should always be one of your first questions. Is this something that I'm aware of? In office hours a couple of weeks ago, we were talking about, your how much food you'd had, and we said, okay, how many calories did you eat for breakfast? I have no idea. That is not information that I am aware of. That would be a lousy survey question, because I'm just going to make something up because That's not necessarily information that's not information that I would be aware of. So you want to make sure that it's information that the participants are aware of, that it's information that the participant's going to have access to, that you've got to be realistic that they're going to forget things. And so if you want to ask them about their memories, you need to keep in mind that they might forget things, that memory might be a distortion. Another limitation of self-report is that you never would think that you're determining causation by just asking, why did you do that? It's a very tempting question to ask, but and it's often we will feel confident and we will generate a plausible reason why we did that. But in science, we would not accept that as evidence of a causal relationship. We might use that to help us design a study an experiment that would then allow us to investigate that causal relationship, but we would not use that as evidence of a causal relationship. So when we evaluate the construct validity of surveys, we're asking the big question, how well was the variable measured? That's what construct validity means. Actually, this is something that the TA said that a number of you struggled with on the exam. When we talk about construct validity, you are plucking one variable out of the study, and you are just talking about that one variable. And so when you are addressing construct validity, it's just how was the variable measured? It has nothing to do with sample size. It has nothing to do with other aspects of the research design. It has nothing to do with the other variable. You just want to focus on one variable at a time. And we'll have time to practice that. But if that's something that is tripping you up, I encourage you to put the time and effort into really practicing this. There are practice worksheets on SmartSite, the Curtis Knows optional worksheets. You could if you go to the textbooks companion site, the author of the textbook also has a blog where she posts current research, recent research, and so that would be a good place to practice this if you're struggling with it. So when we are addressing construct validity, we're asking how well was the variable measured. So we're asking, well, what else influenced the answers given? I mean, hopefully that if I ask you how you're feeling, that how you are actually feeling is influencing the answer you give me. But what else is influencing? What else might be getting in the way? Is there any noise or error that we could avoid? So things to evaluate, the questions being worded clearly to avoid response sets, having a clear layout, thinking about how the survey was distributed. When we talked about that study where the Sweetie Pies sat back to back and were writing surveys, and the first one was your self-esteem. So it was a group of survey questions or self-report questions on self-esteem. The things that would have influenced that, well, one is your actual self-esteem. But the fact that you were sitting back to back with your Sweetie Pie might have changed how you answered those questions. And so thinking about how the survey was distributed, that you're trying to identify if there are other sources of noise or error in the wording that would influence how the participants responded. You might want to consider how motivated the participants were. If they've just filled out 45 minutes of surveys, they might begin to get fatigued and not be reading these so carefully. And then the final piece here is that really querying if the questions were asking appropriate information. So again, that idea of, are they aware of it? Are they aware of the information? Might they be motivated to lie? Is it something that's embarrassing, or is it something that they might be motivated to lie about? And for the most part, we assume that our participants aren't motivated to lie, and I hope that that's the case. This is one of my sort of pet peeves here, is the hypothetical questions. Imagine if you won the lottery, how would you feel? I don't know. That's not information that I can answer. I don't know how I would feel in that situation. If you want to know how people would feel after they've won the lottery, you need to go and find people who've won the lottery and ask them how they feel. So be very aware of those hypothetical questions. So if you are using surveys to measure behavior, and we do this quite a lot because it's quick and cheap and easy, and it gets us close enough to the information. So some things that we can do to improve the construct validity if we are using surveys for asking about behavior. We can ask, so one thing would be to ask about very specific behaviors. Rather than saying, in a general week, in a normal week, how much do you study? Because that's really hard. That's kind of into that hypothetical area. What's a normal week? Is it midterms? Is it finals? Is it, there is no such thing as a normal week. And so a better alternative, if I want to know on average about how many hours did you guys study, I want to say, thinking about the last 7 days, how much have you studied? So it's very specific, and it's much easier then to respond. And now most of you would then be going, oh, but the last 7 days were unusual because it was my birthday, or because it was midterms, but that's okay. That would even out among the group, that there would be fluctuations, but it would even out. So if you are going to ask about behaviors, ask about specific behaviors, and then ask about recent. So last week, but don't ask about, thinking about the first week of the quarter, how many hours did you study? That's probably too far away even now to remember that clearly. Let's see if you can identify these differences between survey and self-report. And these ones are, well, I've tried to make them really clear. So if I was just to sit here right now and say, thinking about the last 7 days, the last week, please remember and let me know, how many hours did you exercise? Is that survey self-report, or is that an observation of your performance? Is everything okay? All right, so I'm seeing a bunch of you there, and 94% of you are accurately recognizing that as I'm asking you to tell me about your memory, your reporting, your self-report. In contrast, if I say, here is a journal, record your exercise every week by writing down the start time and the stop time of the periods of exercise, is that asking you to remember and report, or is that asking you to observe your own performance? All right, and I'm seeing most of you there. And again, we've got 94% are recognizing that 94% are recognizing that is that you are observing your own performance. Is that a perfect way to observe your performance? What would improve the construct validity there? So because you're observing and reporting on yourself, you might fudge the times, you might make things up, there might be other error involved. having someone else, log you in and log you out, or having a video, or that would be more objective. But but we can train you to observe your own performance. It's possible, but yes, it would add some noise or some error. Okay, you know what? Let me not use Wi-Fi. Let me plug in hardline and see if that works. Thank you for letting me know. Let's try another one and see if it works. Were there any other comments on this? Okay. All right. So if I say a series of words will now be displayed, now write down as many of those words as you remember. What am I doing? Am I asking you a survey, self-report? Or am I observing your performance, observing your behavior? Is the Reef app working? I still see the same number of you. Let me restart the Clicker program. So with this one, I'm going to show you a series of words. Now, write down as many of those words as you remember. Is there a right answer to each of those? Is there a right answer? What am I going to do with those words that you remember? I'm going to compare them to the list that I showed you, right? And I'm going to count. You got 5 right. Yeah? I'd be testing your memory. Is that the same as how do you feel about your memory? It's a performance. There are correct answers. And it's then observing your performance on a task. Compare and contrast to So you could be asking yourself, is there a right answer? Will my performance be scored? And if your performance is being scored, then it's like the SAT, and that wasn't self-report. That was an observation of performance. Whereas this one, a series of notes will now be displayed. How confident are you that Apple was on the list? I'm asking for you to survey self-report on your confidence. I'm still seeing the same number of you. I'm still guessing that the Reef app is not working. Let me shut it all down and start it again. Okay. So some key points here. When you're designing observational studies, you are observing, you might be observing actions or performances, you might be accessing archival records. We need to consider, have we minimized observer bias? We need to consider, have we minimized reactivity, the participants' reactions? When you're designing surveys and questionnaires, those are great for measuring thoughts and feelings and beliefs. And we need to address, have we written appropriate questions? Have we delivered the survey in a way that will minimize noise, that will maximize motivation and minimize noise? Questions on those tools? Okay? Then I want to move on to something that's really very different. I want to move on to sampling. All right. So I'm gonna introduce what the concept of sampling is and give you some of the rationale. We're then going to talk about two sources of error, and then we're going to talk about two distinct groups of samples: probability samples and non-probability samples. Here we go. So when we are conducting research, we're interested in a population. And often we're interested in all members of that population. But we're not going to be able to talk to everybody. So what we do is we take a sample from our population of interest, and we'll often refer to it as, the underlying population. And then we need to know if our findings relate to the entire population. We need to know if our sample is representative. Let me give you a little bit of a visual for that. So I've got this cloud that is our population. And I've made it a cloud with the idea that you might not be able to see all the edges. It might not be really clearly defined. So if our population was human beings, there's no list of all the human beings currently in the world right now. And if there was, it would be inaccurate now, right? Because people are dying and being born all the time. And so that is a population that we're never really going to be able to sit down with a list of everybody. Other populations can be really clearly defined. If I'm interested in students enrolled at UC Davis, there's a list of you, right? And that's a really clearly defined population. So our population can be big, it can be small, it can be clearly defined, or it could be really fuzzy around the edges. We're interested in making decisions and understanding relationships between variables of within that whole population. We're not going to be able to talk to all members of the population. And so we draw a sample, and we hope that we need to know whether we have drawn that sample in a way that is representative of the whole population, or if it is not representative of the whole population. If we do try to talk to every member of the population, that's called a census, and we try to do that in this country for once every 10 years to know who is where. And that has the disadvantage of, my goodness, if you miss even one or two people, you've no longer got an accurate census. So when we're doing a census, who do we miss? People go door to door and knock on the doors and say, how many people are living here? Who do we miss? Homeless people. So we miss this whole group of the population, and therefore our census is not accurate, and we can't really confidently make claims about the whole population. I mean, I think we do anyway, and we try. But in some ways, using sampling, where we specifically are just targeting a subset, can produce even more accurate information. It has benefits, and we will continue to talk about this as we talk about the statistics that we use in how we cope with the error in the sample. All right, let me give you an example. So back in 1936, there was a magazine. Are you familiar with magazines? They're like printed, glossy. Yeah. It was called Literary Digest, and it ran polls before presidential elections. And so they kind of, cocky and bragging here. Once again, we're asking more than 10 million voters, 1 out of 4, representing every county in the United States, to settle November's election in October. So there's an election coming up, and in October they send out 10 million ballots to registered voters. So their population of interest are registered voters. Probably registered voters who are likely to show up and vote at the election. And so they've polled, and it's saying that this is 1 of 4. So there's only 40 million registered voters in the country at this time. So they've sent out this huge number of ballots. They got a massive response rate. 2.4 million ballots were returned. And that's actually a very good response rate. Usually when we would send out a survey like that, we would expect a very low response rate, like around 15%. How did they, so there's that was the campaign buttons, Off the Rocks with Landon and Knox. So they want to make a frequency claim. They want to say how many people are going to vote Republican, how many people are going to vote Democrat. And so they know that how they draw their sample is very important. They drew their sample not just from their subscribers, because we all would expect that different magazines and different television channels cater to people who are likely to vote in a group. And so if we only ask people who listen to Fox News who they're going to vote for, that wouldn't be representative of the whole population. So they knew that. And so they drew their sample from telephone directories, from car registration, from magazine subscriptions. And they predicted that Landon was going to win 57, though their response rate, their responses, Landon got 57% of the vote, Roosevelt got 43% of the vote. And so they announced, settled November's election in October. Landon is going to be our next president. Have you heard of President Landon? Not so much, huh? The actual results, Landon got 38% of the votes and Roosevelt 62%. Landon only carried 2 states. So he only got 8 electoral votes. And so it was this massive landslide where, all but 2 of the states voted for Roosevelt. And that was their cover the next week, the next month. Boy, is our face red. So where did they go wrong? How? I mean, there was a huge sample. Why did they get it so wrong? Yeah. Okay, so it's got to be not representative. And maybe we look at this and we say, cause, what was going on? When was this? This was 1936? Yeah, what was going on? Are you familiar with 20th century history? The Great Depression was, the 30s, 40s was people didn't have cars, people didn't have homes. People were, they didn't have telephones. The group of citizens who had telephones, cars, and houses to which magazines could have been delivered are very different from the group that didn't. So let's see if we can think about that. So their population of interest was registered voters. And we've just said, hang on a second, we could look at that population and say we're going to divide it into rich people and poor people. And that the rich people have cars and have magazine subscriptions and has phones. And, some of the poor people are going to have some of those things as well. But that those 3 subpopulations are more over on this side of that population cloud. And then when they drew their sample, they drew their sample from those 3 groups. And they ended up with mostly rich people who were mostly voting Republican, and they missed a whole section of the population, and therefore so we could look at it again as Republicans and Democrats, that they made the wrong prediction because even though they had tried to draw a sample from a wide set of sources, they had ended up mostly sampling Republicans, not sampling the Democrats, and were inaccurate in their frequency claim. So when we talk about sampling, we are talking about external validity. Another word for external validity is generalizability. When we talk about external validity, we're asking, do these results apply to the entire population? We need to know, is our sample representative? Can we say, these 2.4 million people say this, and therefore the 40 million voters will say roughly the same? So does it apply to the entire population, or even to other groups, or other settings, or other situations? If we have a representative sample, we will have stronger external validity. If we have a non-representative sample, we will have weaker external validity. So we've been talking a lot about construct validity. This is a different concept using that same word validity of, is it true, is it accurate, is it valid? And this time we're asking external, when we go to make predictions with these results, will these results generalize back to the whole population or to other settings, other situations or other settings? Let's see if the clickers are working again. So external validity is most important when we are establishing a or an So if you recall, a couple of weeks ago, we went through the different claims and the different validities. And I know that your book really pounds on this. And on the front cover, inside of the front cover, she's got the 4 validities and the 3 claims. And so when we are concerned with external validity, let me start that sentence again. We often sacrifice our external validity. We often really don't care, and we just throw it out because we are trying to maximize our internal validity. And those two are kind of on a seesaw where one goes up, the other goes down. The only time that we're really that concerned about our external validity is when we're making a frequency claim. If we're making causal claims or association claims, we're often doing it with students in Psych 41. Are you guys representative of people? I mean, you're all people, right? Are you representative of people? No, you're a really narrow age range and education level and intelligence level and geographic location. And whatever we learn about you doesn't have huge external validity to transfer to other groups. But that doesn't mean that we can't establish that there are associations between variables or causal relationships between variables within this sample. So we will often quite happily sacrifice our external validity. This is an envelope that came through my mail a while ago now, a few months ago. So it's from UCLA, the Center for Health Policy Research. And I open it up. And lo and behold, I find that there was a $2 bill in the envelope. And your household has been selected for this year's California Health Survey. This important telephone survey, your opportunity to have your voice heard on health issues. Your household is very special. You're part of a scientific sample representing many other households like yours. We'll call sometime in the next 2 weeks. Please answer the phone. And here's $2, just so that you remember to answer the phone. What are they attempting to do here? Excite me? Yeah, I mean, I don't even think $2 is going to bribe me, but why? Okay, so I'll have an incentive to do the survey. Why is it important to them that I do the survey? Because it's a random sample, and they want to maximize their external validity. So they've had a list of every household in California, and they have selected a sample, and my name happened to be on that list. And so they want to do everything they can to make sure that the people that were on that list were motivated to be part of the survey. So they're trying to increase their external validity by really reaching out to the people who have made it into their sample. Who knows? Because it's cute. So when you're making a frequency claim, you want to make sure that you've got your sample, that your sample is representative. All right. Let's talk about some error in sampling. There's always going to be error. When we say error in sampling, that means that the extent to which the sample differs from the population. So there will always be error. There is what we call sampling error that just says no two samples will be the same. There will be variation. This is random. And we're okay with it. It is also possible to have sample bias. If we selected our sample systematically, if we introduced constant error, then our sample is going to be biased, and that's not okay. Let me take some samples. Let me show you what I mean. So I have a tub of 10,000 beads. What's the variable? Color. Do you see what colors do you see? Yellow, white, green, red, black, purple. Awesome. I have a little sampling stick. It's the cutest thing you've ever seen. That I'm going to dig around in here, and I'm going to pull out a random sample. Isn't that fun? So, let's see if we can make a frequency claim. Let's draw a random sample of 10 to make a frequency claim. So, because I want to know, of my 10,000 beads, how many are white, how many are green, how many are black? So tell me, how many white? How many green? How many red? 2. And I'm just focusing on those 3 colors because they are the most frequent. How many white? Oh, it's light blue. So there are 5 white, 2 green, and 1 red, and then there's a light blue and a purple. There are 4 green. Oh, it looks black. It's green. And no red. Five white, 3 green. You guys are all like, I don't know. That one's black. That one's red. 1 red. 1, 2, 3, 4, 5, 6. 1, 2, 3, and 1. All right. Let me put that aside for a second. I'm always terrified I'm going to drop it and we're going to have 10,000 beads on the floor. So we took 5 samples. This is what it looks like. How would we make our frequency claim? What would we do with this data? Well, first off, were all the samples the same? No. There was variation, right? Was that because I was, picking them out and putting, was I systematically selecting white beads and red beads and green beads? No. I was just randomly sampling. No two samples are going to be the same. That's fine. That's sample error. That's just variation. So how are we going to determine, what are we going to do with the data? There were 10, so this was 5 out of 10, 4 out of 10, 5 out of 10, 6 out of 10, right? So what's our average here? If we just looked at the 5, 5, 4, 5, 6, the average is 5, right? So 5 out of 10, we could turn that into a percentage, couldn't we? Yes? Do you believe me? It's 50%? Yeah? Okay. So we would say, I think that this tub is 50% white. Based on my sampling, I make a frequency claim that this tub is 50% white beads. What percentage do we think for the green beads? Wow, this is so easy to average. 3, 3, 3, 2, and 4. 3 out of 10. So from these 5, we think that there's 30% green. And then 2, 1, 1, 1, 0. 1, 2, 3, 4, 5. 5 by 5 is 1, right? One, 2, 3, 4, 5. In 5 trials. That's right, isn't it? Okay, all right, I'll say it confidently. We think that 10% of the beads are red. So this is how we would make a frequency claim based on drawing a random sample. There's going to be error. No two are the same. That's not all. I could increase my sample size because look, I have another paddle and it's got 25 slots. I actually have 2 more at home, but they don't fit in the tub. 2, 4, 6, 8, 10, 12 of my 25 are white. Do you see how consistent this is seeming? That even with a larger sample, ooh, there's a whole bunch of green there. There's a whole bunch of white there. There's going to be variation. There's going to be, no two samples are going to be the same. There's random error. It would be possible to have sampled 10 white beads in the group of 10. Do you think the larger sample is going to be more accurate or less accurate? More accurate, yeah, absolutely. Increasing the sample is going to make it more accurate. All right, put my beads away for a minute. So here's the idea of those beads, that the whole population in that cloud, and that we drew samples, and that they were there was some variation, there's some error, but that they are, if they were drawn at random, that they would be representative of the population. So how do we deal with sampling error? One way is to increase your sample size. So the larger the sample size, the closer it will be to your population within limits. So here is a table from your book that says, if your percentage is estimated on a sample size of this, your margin of error is this. You've heard this concept of margin of error, and boy, you're going to hear it a lot with the presidential elections coming up, where they're going to say, you're getting, 18% of the vote, plus or minus 2. And so that's saying right now we're measuring it at 18, but it could be as low as 16, or it could be as high as 20. So this, so from that sample where we said, okay, so we've got 5 white out of 10, we think it's 50% plus or minus a margin of error. So if our sample size is quite small, like 50, we've got this huge margin of error, 14%. We're not very accurate at all. If we double that to 100, our margin of error drops to 10%. If we double that to 200, our margin of error drops to 7%. By 500, it's dropped to 4%. And then it doesn't really drop very much more from there. That there's always going to be sample error. You can't squeeze it out completely. You can't eliminate it completely. A larger sample size gives you a more accurate estimate, but within limits. That after 200, 500, you really don't gain that much more. And it's certainly possible to see effect even with a sample as small as 50 or 100 there, as long as it was a big effect. Yeah. So the question is, do those numbers change depending on how big your population is? Is that the question? So, and the answer is kind of, it doesn't matter. That if your population is the students at UC Davis, so 35,000 students at UC Davis, these numbers would be the same as if your population was voters in the state of California. The big difference would be if your population was really variable. If there were a lot of different subsets, meaningful subsets in your population. So in the voters in California, there's city, there's rural, there's north, there's south, there's a lot of different groups. And so you'd want to make sure you were sampling from all of those groups. But the point is that your sample size, that yes, it's good to have a big enough sample, but that it doesn't have to be crazy big. I think a lot of students, when they start learning about research methods, kind of glom onto the idea that they can go, oh, well, this only had 40 participants, so that's a small sample size. And that's often not a particularly interesting critique of research. For one thing, this is only when we're talking about external validity. So it's only relevant if we're saying, therefore, we think that this is how people are going to vote, or therefore we think this is, the something that's relating back to a population. And it's really, well, there we go. So it's only really relevant if we're talking about external validity, if we're talking about generalizability. And so we estimate we give ourselves these margin of errors. We estimate using statistics. So we'd say, the average of those white beads was 50%, and then we'd say with a margin of error of 45 to 55%. We'd be certain that it was in between those two. So we're able to estimate how much sampling error there is based on the variability in our sample. The other source of error in a sample is sample bias, or constant error. And this is just bad. This is evil, wicked, and wrong. So if you've got a non-random selection procedure, like I'm only going to ask people who have cars and phones and magazine subscriptions, then then you're going to bias your sample. Your sample is not going to be representative of that population. If I say I'm going to, just ask people, I want a survey, so I'm going to just go and stand outside the MU and ask students as they go by what their priorities are. That's not going to be that sample is going to be biased by the people who hang out at the MU, the people who have classes around the MU, the people who are on campus at that time of day. And so there's going to be, that's not going to be representative of the whole population. If you let people self-select, that's not going to be representative of the whole population. It's going to introduce sample bias. And so that would reduce your external validity. You would not be able to draw conclusions back to the population. All right. So we've talked about kind of what we're talking, the introduction, we talked about two sources of error, and we've been talking a little bit about probability samples and non-probability samples, but let me go ahead and define those for you. So we split samples into two different groups. There are probability samples. Those are representative of the population. They will be very similar to the population. We work to reduce sample bias, and if we have a probability sample, we are confident that we have strong external validity. If we have selected a non-probability sample, that's not going to be representative of the population. It might not be similar to the population. There almost certainly is sample bias. There's systematic constant error, and it's going to have weak external validity. Let's start by talking about the probability samples. So there are two ways of getting a probability sample. One is a simple random sample. There are two simple steps. I think whoever called it simple random sampling was just being facetious. There's nothing simple about it. Two simple steps. Oh, the first simple step, just identify all the members of your population. And so, as we talked about at the beginning, if your population is really clearly defined and all your names are on a list, then that is a simple step. But if your population is less well defined, that's impossible. And so we would never be able to draw a simple random sample of human beings, or even like adult Americans. We just couldn't do it. There isn't a list. So you've got to identify everyone, and then you have to choose your participants, such that every member of the population has an equal likelihood of being selected. So if I wanted to draw a random sample from people enrolled in Psych 41 this quarter, so my population of interest is you guys in this class this quarter, can I identify every member of the population? Yes, because I have a list of you guys, right? My side of the gradebook has 300 names. And then what would I do? What are some ways that I could select a sample such that every member has an equal likelihood of being selected? What are some things that I could do? To draw a name from a hat? Okay, so I could print up 300 names, cut them into strips, put them in a hat, pull out 20 of them. Would each of you have the same chance of being selected? Yes. Yeah? Okay, so we could put them into an Excel spreadsheet. Excel will generate a random number and then sort by those random numbers and just say, I'm going to take the ones that got the lowest, the 20 that got the lowest random numbers. Oh, that was what you were going to say? Okay, so yeah, and Excel does, it generates a random number for you, and then you just say, I'm going to pick the lowest 20 or the highest 20. What else could we do? What other randomness do we have access to? Could we flip a coin? We could. I mean, so we could go down each name and flip a coin and say, I'm going to eliminate everyone who gets heads. Okay, so we would expect half of the group to be eliminated, and then if that's still too big a sample, maybe we go down and go, okay, I'm going to do it again and eliminate everyone who gets a head. And so we'd be down to a quarter of the group. We have a dice. I'm going to roll a die, and I'm only going to select the ones that got a 6. As long as I consider every member of the population, and I do something that is non-systematic, and I don't just go, oh, I like the look of that name, or I sort you by the score on your midterm and then take the top 20. I want to make sure that every member has an equal likelihood of being selected, that it's non-systematic, that it's random, that I select a random sample. And if I do that, well, the extent to which I do that, it will be the extent to how representative my sample is of the population. And if I do it successfully, I'll be able to draw conclusions back to the entire population. So that's one of the ways of getting a representative sample. Another way of getting a representative sample is called stratified sampling. We start by identifying all the members of our population. We need to gather more information about them. We need to not just have their names on a list, but we need to have some information about them, because we need to identify meaningful subgroups. So in our population of people enrolled in Psych 41, what are maybe some meaningful subgroups? So what your major is, ethnic background, age, grade point average, year in school, transfer, non-transfer. That might be, we could think of all sorts of different ways of dividing that. And actually that was what we were just talking about. If we wanted to look at voters in California, we would want to stratify it by rural, urban, north, south, these different counties or different areas of the state. Is that why you did the pre-screening survey? So the pre-screening survey for the SONA system, your participation points, that was a lot of demographic information and then a lot of just other potential predictive variables. And I think the point is that the different studies will have access to that. Certainly some studies are looking for, they only now need males who are native English speakers or certain groups of the population. But so yes, I mean certainly that would have some degree of this. But I doubt that any of the studies that are going on right now are concerned with their external validity. Because they're just you guys. And you're not, I mean, it's only people enrolled in psychology classes. You're not representative of UC Davis students. Because they are looking for causal claims or for associative claims. They're not looking to make frequency claims. So we gather all this information. We identify meaningful subgroups. We then divide our population into those subgroups and randomly select proportional samples from each subgroup. So if I wanted to do a stratified sample with my beads, I would need a whole bunch of other tubs, right? I would need to get my children to sort through the 10,000 beads and put all the white beads in one group and all the green beads in one group and all of the pink beads in one group and all of the blue beads in one group. And then I would determine what are the proportions in that population, and I would select my sample randomly within each group proportionally. This is really a good idea if you are afraid that you're going to miss an important subgroup. If you have a little tiny minority group, so in our beads, there's only 5% are the pink beads. I could sit here and draw random samples all day and never get a pink bead by random sampling. If it's important to me to make sure that I've got every member or every subgroup represented, then let's see. I start with here's the color, the variable, the color. I need to know what proportion they are in the population. And so I know, because I didn't go ahead and count them, but they came with a piece of information that told me that it was 50% white beads and 25% green beads and 0.5% pink beads. So if I want a sample of 200, I want 50% of that 200 to be white. How many will I draw from the white tub? 100 beads. I want 25% of that sample to be green. How many am I going to draw from the green tub? I want 0.5 of that sample to be pink. So what were you guys doing here? You were taking 50%. You were going half of 200 is 100. 25% of 200 is 50. 0.5% of 200, what is it? 4? 1? 1? So in my group of pink, I would randomly select one pink bead and put that in my sample. So I have stratified my population. I've divided it into meaningful subgroups. I have determined we know the proportion. I let the population tell me what proportion it is, and then I decide on my sample. Let's do another example. So if I want to do a stratified sample of Psych 41 students, let me say that we're going to look at first year, second year, third year, fourth year, and above. There are 300 students in the class. So I've counted how many first year, second year, third year, fourth year, fifth year students are there. This is what is in the population. So what's the proportion of first years? What do we do? 50 out of 300, right? Yes? Because there are 300 in the population. So what's 50 out of 300? So 16%? Oh, that's 1 out of 6. Okay, I'm good with 16. So then what's 100? So it's 100 out of 300 is 1/3. Yes? Do you see what we're doing? $25 out of 300. So if I want to then take a sample of 20 of you guys, and I want to make sure that I've got a proportional number of first year, second year, third year, fourth year, and above students, how many of my sample of 20 are going to be first year students? So it's 16% of 20. .16 times 20. Someone got a calculator? 3.2. 0.33 times 20. .08 times 20. I think it's 1.6. Okay, so it's really hard to select a 0.2 of a person. So I probably just say I'm going to have 3, 7, 7, 2, and 2. Did I get pretty close to a sample of 20? And is it proportional to the population? So I would now take all of the first years, those 50 names, on strips of paper, put them in a hat, and draw 3 of them. I would then take the 100 second year students and put them in a hat and draw 7 of them. And the 100 third years and draw 7 of them. This maintains every person has an equal chance of being selected. If you were, one of these 25 out of 300, you've got a 1/12 chance of being selected, just like you do if we stratify it. We're just ensuring that we talk to every important subgroup. So what are the advantages of stratified sampling? So we can accomplish representativeness with a smaller sample, and it ensures that we don't overlook a minority group. If we've got a small minority group, this ensures that we will draw proportionally from that minority group. It's representative. It's a probability sample. Therefore, we will be able to draw conclusions back to the rest of the population. So we've just done this, but if this is our population, we count how many are in these different subgroups. So we've got a population of 30. Step 1, so we count the subgroups. Step 2, we calculate our proportion, so 6 out of 30, 9 out of 30, 15 out of 30. Step 3, we say, okay, we're going to set our sample size at 10. Step 4, so what's 2/10 of 10? Easy. So we calculate the sample size for each group, and then we would go back into that group of 6, and we would randomly select 2 of them, back into that group of 9, and randomly select 3 of them, back into that group of 15, and randomly select 5 of them. And so our population, our sample would look exactly like our population. It would be stratified. Stratified means in layers, right? You've heard that in other classes or in other terms. You might hear it in cooking, where you've got layers or strata, or in geology, where you've got layers. We're using the same term, stratified, layers. All right. Okay, so this is, again, the same idea of you would calculate, you know the percentages in the population, and then you choose your sample size. You let the population determine what proportion of each group is going to be in your sample. So some practical considerations with probability sampling. It can be really hard to identify all the members. Another practical consideration, selection doesn't ensure participation. You know, they sent me that $2 bill. I still didn't answer the phone because I don't have a phone. I mean, I've obviously got a phone number. It's not hooked up to a phone. So, but just because they selected me, they went out of their way. They sent me the letter saying, please answer these questions, because they're trying to ensure, try to make sure that everyone in their sample does participate. But just because you're selected doesn't ensure participation. As soon as you have people who have not participated, then your sample no longer looks like your population, because the group that don't participate are going to look different from the group that do participate. So as soon as you've got self-selection, you've got sampling bias, and your external validity starts to get chipped away. So one thing that we try to do maybe is get some information about the non-respondents. Have you had the phone surveys, and they say, well, just I can't answer all these. Well, just are you male, female? What age range are you? Just to get some information about you, so that they can try to track. Is there a particular subgroup that we're missing? So that's with probability samples. We really rarely do probability samples. In psychological research, we're mostly interested in associative claims and causal claims, and we really don't care about external validity. We are maximizing our internal validity and sacrificing our external validity, and we are just fine about it. We sleep well at night. It's okay. Now, in other areas, if you were, really trying to describe a group, obviously your external validity is going to be critical. But for the majority of psychological research, we have pretty low external validity, and we're okay with it. So let's talk about the non-probability samples. So these ones are not representative. We know they have sample bias. We know that they have weak external validity. And here are 4 that I want to talk about. The first one is a quota sample. Oh, they have low external validity. Yes, I told them that. So a quota sample. Quota samples are really similar to stratified sampling. The big difference is that the research question sets the quota. So the researcher sets the proportions. We're not interested in our external validity. We're not interested in making sure that our sample looks like the population. We're interested in some other research question. And instead of saying, well, 16% of the group was freshmen, therefore I'm going to select 16% of the sample to be freshmen, we're going to say, no, I just want to make a comparison. Let me give you an example. So if we were interested in work-life balance and attitudes towards work-life balance, so I wonder if gender is related to a boss's attitude towards work-life balance. I wonder if men or women, when they are bosses, if their attitudes are, if there are differences between their attitudes. So let's look at the most successful corporations. So let's look at that list, the Fortune 500. Those are the top 500, the 500 top earning companies. So that's my population. The CEOs of the Fortune 500 companies. I want to know what their attitude is towards work-life balance. How they gotten, what do they want from their employees? Is it, chain you to the desk and just work 70 hours a week? Or is it, oh no, it's really important to be a fulfilled person? Oh look, they're 95% male. There are 476 male CEOs of Fortune 500 companies and only 24 female CEOs of Fortune 500 companies. So if I want to compare gender to attitude towards a work-life balance, wow. If I draw a random sample, I'm never going to speak to these females, right? Because it's all men. It's all men. So here's my population, CEOs of Fortune 500 companies. So if I draw a random sample, it's going to be, I'm going to get so many men and never get any women, right? So if I just said 20, I'm going to talk to 20 people. So that would be 4% of the population. So I'm going to talk to, 19 guys and one girl, 19 men and one woman. That's not going to let me really address my research question. So that would be maybe a random sample of 20 of them. So instead, let me just set the quota. So I don't care about external validity. I'm not trying to make a frequency claim. I'm trying to make an association claim. So I'm just going to set the quota to 20 in each group. I'm going to select 20 of the males and 20 of the females. And I'm going to interview those 20 in each group and compare their answers. And I'll be able to say, male CEOs of Fortune 500 companies have this attitude, and female CEOs from Fortune 500 companies have this attitude. And I'll be able to compare their attitudes. Yeah. I separate the two groups. I do a random sample of each group, but I'm not worrying about making it proportional. So the difference with the stratified was I wanted to make it sure it's proportional. Whereas now I'm just throwing out the proportions in the population and saying, in order to address my research question, I'm going to talk to 20 females and 20 males. So if you are a female, remember how many there were? 24. What is your chance of being selected into this sample? Very high, right? Nearly 100%. If you were a male CEO, there were 476 of them. And I'm going to select 20 at random. What's your chance of getting selected? Very low. So does every member of the population have an equal chance of being selected? No. So we can tell that it's not a random sample. It's not a simple random sample. It's not a stratified random sample. It's not a probability sample. It's a non-probability sample. We're calling it a quota sample. It's very like that stratified one. The big difference being that I set the quota, I set the proportions, not allowing the population to set the proportions. So this is if we've got a specific question and we want to target different subgroups to compare their experiences, to compare their attitudes or their behaviors. Another sample we might take, these are in the non-probability samples. There's a purposive sample, where I have a purpose in mind. I'm going to select specific subsets to compare. I am selecting them systematically. It is not random. I'm not trying to make generalizations. So if I want to address the question, what makes a successful Psych 41 student? I might select a non-representative sample that will exaggerate the effects. So I might compare, I might look at, right now, after your first midterm, I'm going to select the top 10% of the class and the bottom 10% of the class. And then I'm going to interview those students and say, what were your prereqs? What, are you interested in this? What's your major? How much time are you putting in? Are you reading the book? I ask all sorts of different questions that will maybe let me see the difference between what makes a successful Psych 41 student and what makes a not successful Psych 41 student. Is it representative of the whole class? No, it's exaggerated. I have chosen those that are walking on water and those that are floundering. Because I want to exaggerate the effects and see if I can see a difference between what makes, who ends up in one group, or what variables, what relationships go together. Because then the next quarter I could say, hey, if you have these characteristics, I predict you're going to do great. If you have these characteristics, I predict you're going to not do great. You better work harder or work differently. So that would be a purposive sample where we've got a specific purpose in mind. We've selected a sample that's not representative, that exaggerates the effects. Another type of sample we might select is called a snowball sample. So this is the idea that as our snowball rolls down a hill, it gathers more snow and it gets bigger. That's why we call it a snowball sample. Have you heard that concept? So if we're interested in a really hard to access population that there isn't a list of, I used to use the example of gays in the military, because there was this whole, you weren't allowed to be there, so there certainly wasn't a list of them. But that if you could find one, you might be able to ask them, do you have any leads for me? Do you have any other people that you could suggest that might be in my population? I was working with a student who wanted to look at couples who were divorcing after more than 20 years of marriage. It's an interesting population. It's hard to find. But if you can find one, they might know other people in a similar situation. They might be able to put you in touch with other people. And so when you're interested in a hard-to-access population, have each member you find recommend additional members. And your sample will snowball, will grow as it rolls downhill. It's not representative. It's not probability. But it's a way of accessing a sort of a hard-to-access population. The most common sample is a haphazard or convenient sample that is just using what's convenient, using what walks through the door. And that's most research. Just sign up for your SONA studies. That's a haphazard sample or a convenient sample, and it is absolutely the most common. There are ways that we can improve the representativeness of those non-probabilistic samples. So we can use procedures to minimize selection bias. If we want to just go to the mall and ask people, we can say, okay, I'm going to ask every third person who walks past me. And so that would improve the probability a little bit, the representativeness a little bit. We could also sample from a broad variety of times and places. All right, I've run out of time. I have to let you guys go. I will see you on Tuesday.